Hello students. Now we will discuss an important concept in the propagation of sound, that is Newton's formula and Laplace correction. As we studied, sound is a longitudinal wave. Longitudinal wave travels in the form of compression and rarefaction. Compression means the coming closer of the particles, rarefaction means moving away of the particles. And we know these two properties are required for the propagation of wave. First is elasticity and second is inertia. So, Newton's formula for propagation of sound, was velocity of sound in air or vacuum was an isothermal process. According to Newton, the propagation of sound in a gaseous medium is isothermal. According to Newton, he said whenever the particles come closer, temperature increases, and when the molecules move apart, the temperature decreases. Again in compression, temperature increases, and in rarefaction, temperature decreases. According to Newton, propagation of sound is an isothermal process. He proposed that the propagation of sound is isothermal because in the process temperature remains constant, and he equated this expression with pressure upon rho. His logic was there is an increase of temperature during compression because the molecules undergo friction. As a friction, temperature increases, and when the molecules move apart, the temperature decreases. Wherever there is expansion, there is a decrease of temperature. As a result, the increase of temperature was compensated by the decrease in temperature. As a result, the temperature was constant. And on calculation, the value was around 280 meter per second. But this value did not match with the experimental result. There was a scientist called Laplace. He corrected it. So it is known as Laplace correction. According to Laplace, the propagation of sound in a gaseous medium is an adiabatic process, जिसको हम हिंदी में रुदोष्म प्रक्रिया कहते हैं. Adiabatic process means a process in which there is no exchange of heat between the system and the surrounding. According to Laplace, air is a poor conductor of heat. As we all know, हवा ऊष्मा का कुचालक है. According to Laplace, the amount of temperature increased in compression does not passes to rarefaction. Whatever temperature increases in compression does not pass to rarefaction. As a result, the process is adiabatic. So, according to Laplace, the velocity of sound is an adiabatic process, K adiabatic upon rho, and it was equated with gamma P upon rho. This gamma is a adiabatic constant, right? So, according to Laplace, propagation of sound is an adiabatic process क्योंकि जो हवा है वो कुचालक है. कुचालक means it is a poor conductor of heat. As we can see so many examples during winters, the birds swell their bodies. आप लोगों ने देखा होगा कि जो है सर्दियों में पक्षी अपने शरीर को फुला लेते हैं बिकॉज उनकी बॉडी की हीट बाहर नहीं जा पाती. एयर इज अ बैड कंडक्टर. दूसरा हम प्रैक्टिकल एग्जांपल देखते हैं. अ न्यू क्विल्ट इज वार्मर देन द ओल्डर वन. जो नई रज़ाई होती है वो पुरानी रज़ाइयों से ज़्यादा हमें ऊष्मा या गर्मी देती है बिकॉज अ न्यू क्विल्ट हैज़ गॉट एयर पोर्स. वो फ्लफी होती है, उसकी हवा बाहर मतलब उसमें से जो हीट है वो बाहर नहीं जा पाती. लेकिन जो पुरानी रज़ाई होती है उसमें एयर ट्रैप नहीं होती, उसका जो कॉटन होता है वो कंप्रेस हो जाता है. सो अकॉर्डिंग टू लाप्लास, प्रोपगेशन ऑफ साउंड इज एन एडियाबेटिक प्रोसेस एंड गामा ऑफ एयर, द एडियाबेटिक कांस्टेंट ऑफ एयर इज 7/5. ऑन सॉल्विंग this velocity of sound comes to be 340 meter per second, which matches with the experimental result. So Laplace correction is considered as the most correct form of the velocity of sound in gaseous medium. Though Newton's assumption was correct at that point of time, but we all know science progresses in that manner. Correction is done with due course of time. So the modern version of the propagation of sound in gaseous medium is considered as Laplace propagation of sound. Then there is a very important topic called plane progressive wave. Plane progressive wave or travelling wave or harmonic wave is a wave which travels from one point of the medium to another. कोई भी ऐसी तरंग जो किसी भी मीडियम में एक पॉइंट से दूसरे पॉइंट में जाती है, this is an example of a plane progressive wave. The plane progressive wave may be transverse, it may be longitudinal. Mathematically, plane progressive wave is given by y is equal to a sine kx minus omega t plus minus phi. This y gives the displacement of a plane progressive wave. This a is the amplitude जिसको हम हिंदी में आयाम बोलते हैं. K is called propagation constant. This K is propagation constant. Propagation constant is given by the ratio of omega upon v. Omega is 2 pi nu, v is nu lambda, and omega we all know this is angular frequency. Angular frequency is given by the ratio of angle upon time. For one revolution angle is 2 pi or one oscillation, and the time period is capital T. We all know 1 upon time period is frequency, so this is 2 pi nu. This small t is any instant of time, कोई भी क्षण या पल. This phi is called phase angle or phase difference. हिंदी में इसको कलांतर कहा जाता है. Say this is one wave. So phase angle gives the time and the angle. I mean the relation between the time and angle. Suppose initially the wave is here, so t is equal to 0. Here t is equal to t by 4. Here this is the half of one cycle. This is t is equal to t by 2. This is t is equal to 3 t by 4. This is one complete cycle. T is equal to capital T. Capital T is the time period of the plane progressive wave. It is also known as harmonic wave. It is also known as travelling wave. A wave which travels from one point of the medium to another. Mathematically it is given by y is equal to a sine, either it may be omega t minus kx or kx minus omega t, and there is a sign convention also. The waves which travels in the positive x-axis, we take the negative sign, and the wave which travels towards the positive x-axis, we take the negative sign, and the wave which travels along the negative x-axis, we take the positive sign. ये साइन कन्वेंशन है प्लेन प्रोग्रेसिव वेव के लिए. और k प्रोपगेशन कांस्टेंट को हम लोग एंगुलर वेव नंबर भी बोलते हैं. k is given by the ratio of angular frequency to linear velocity. Omega is 2 pi nu. Velocity we all know that is nu lambda. Frequency is constant, so propagation constant is 2 pi by lambda, and omega is angular frequency, that is 2 pi nu. So we can have numericals based on the concept of plane progressive wave. Thank you.